Welcome to SPCL bonds. So, in the last class we have seen the reactivity series. Now we have to see the displacement reactions. There is a relation between reactivity series and displacement reactions. Let us see actually what is displacement reactions. Okay. So listen, for that there is an experiment. Prepare some copper sulfate solution in a beaker. Copper sulfate, it's a blue colored ionic substance, Copper sulfate solution, prepare a solution in a beaker and dip a zinc rod in it. Observe the changes after some time. So we can see the change. There is a diagram, there is a figure, and in that figure, on that photo, we can very easily find the difference between that means before the experiment and after experiment. There is a difference. So initially there is a blue color, and that means an observable change is there. A dark blue color is there in the copper sulfate solution, but after some time the color is vanished. Number one, or decreased. Number one. Number two, the zinc rod is a smooth one, or zinc sheet is a smooth one in the initial stage. But in the that means after the experiment we can see something is captured on the surface of this zinc rod. So what happened to this zinc rod here? What happened? So zinc rod is converted to that means something is captured. Something is captured on the surface of zinc rod. Okay, that's okay. Then what is the reason for this? What is the reason? What is the reason for the change in intensity of the color of copper sulfate solution? You think about that. What's the reason for this change of zinc rod, and what's the reason for the change of intensity of color of copper sulfate solution? You think about that. Okay, you can explain very easily based on certain observations. The blue color of copper sulfate solution is due to what? Due to the presence of Cu2 plus ions. Cu2 plus is an ion which can produce blue color, because copper is a d block element. So almost all d block elements can produce ions which can produce colored compounds, which can form colored compounds. So Cu2 plus can produce blue color. So copper sulfate is blue colored solution substance. So the blue color of copper sulfate solution is due to the presence of Cu2 plus ions, no doubt. Okay. When the zinc rod is dipped in copper sulfate solution, the Cu2 plus ions in the solution get deposited at the zinc rod as Cu atoms. So Cu2 plus is converted to Cu atom. So Cu2 plus ion is converted to Cu atom, and the Cu atoms are deposited on the zinc rod. That's why there is a change in the shape of zinc rod. Zinc rod is converted to an ugly look. That means it is converted to an ugly material. That means some blisters are formed at the surface of the zinc. So that means something is captured on the surface. That captured materials are Cu atoms actually. So a large number of Cu atoms are deposited, so it is converted to a particular style. Okay. The chemical reaction taking place here is given below. So you observe the chemical reaction. Zn plus CuSO4 gives ZnSO4 plus Cu. What happened here? Zn is the metal, CuSO4 is a solution, the ionic solution. From that ionic solution, Cu is displaced. So from CuSO4 solution, Cu is displaced, and you get a zinc sulfate solution. So what happened here? Zinc can displace Cu from copper sulfate solution, and copper is obtained. Copper atom is obtained, or metallic copper is obtained. Which is the metal that gets displaced here now? No doubt copper. Okay, the metal which is displaced in this reaction is copper, no doubt. Which is more reactive, zinc or copper? No doubt zinc is more reactive. So zinc is more reactive, and zinc can displace copper from copper sulfate solution. On the basis of the position of zinc and copper in the reactivity series, can you explain why Cu has been or had been displaced? Cu had been displaced by zinc. Copper had been displaced by zinc. You explain this activity, this reaction based on this process, based on the activity series or reactivity series. Zinc is in the upper position of this reactivity series, because zinc is more reactive than copper. So zinc can displace copper. Is clear? Isn't it due to the higher reactivity of zinc when compared to copper? Yes. Okay, the reactivity of zinc is more than that of copper, so zinc can displace copper from copper sulfate solution. So electrochemical series helps us to explain this type of reactions. Okay, Then let us rewrite the above equation showing the nature of the ions as below. You write the equation again. But in this equation, we are representing the ions also. That means oxidation number of each element or each radical is expressed here. So Zn, the charge is 0, oxidation number is 0 because zinc is a metal and zinc is an atom, zinc is an element, so zinc is a metal. Okay, so oxidation number of zinc is 0. But in zinc sulfate, in the right hand side, zinc sulfate is there. So in zinc sulfate, the oxidation number is +2, not 0. So Zn0 is converted to Zn2 plus. Then what about copper sulfate? In CuSO4, the oxidation number of Cu is Cu2 plus. Okay, so you have written all the elements or radicals or ions in the form of ionic forms. That means Zn0, then Cu2 plus, SO4 2 minus, then again Zn2 plus, SO4 2 minus. But copper is 0, Cu is 0. What happened here? Cu2 plus is converted to Cu. Similarly, Zn0 is converted to Zn2 plus. The change that happened to zinc is, it is very clear. What happened here? Zn0 is converted to Zn2 plus. So equation Zn0 gives Zn2 plus plus 2 electron. Is clear. That means 2 electrons are removed from Zn. What is removal of electron? Removal of electron is oxidation. Therefore, this reaction is oxidation. Is this reaction oxidation or reduction? Oxidation. Why? Electrons are removed. Moreover that, there is another concept. What is that? Oxidation number is raised from 0 to +2. Oxidation number, increase in oxidation number is called oxidation. Okay, increase in oxidation number is oxidation. So 0 is converted to +2. So increase in oxidation number is oxidation. Similarly, the removal of electron is also oxidation. So what happened to zinc here? Zinc is getting oxidized. So this reaction is oxidation reaction. What happened to Cu2 plus? The change that happened to Cu2 plus, what happened? Cu2 plus plus 2 electron gives Cu. Cu2 plus plus 2 electrons gives Cu. What happened? 2 electrons are added to Cu2 plus. So addition of electron. What is addition of electron? Is it reduction or oxidation? Reduction. So addition of electron is reduction. So what happened here? Cu2 plus is reduced. Cu2 plus is reduced. Here what about oxidation number? 2 plus is converted to Cu0. Okay. So plus 2 oxidation number is converted to 0. That is reduction. Reduction in oxidation number is called reduction, or addition of electron is called reduction. What's the name of this reaction here? Reduction. Why? You know, now what's the reason for getting the name reduction? What is reduction? Addition of electron. Otherwise, decrease in oxidation number. Now we can see in this equation, that is Zn plus CuSO4 gives ZnSO4 plus Cu, we can see both oxidation and reduction. Both oxidation and reduction are associated here. That type of reactions are called redox reaction. So Zn is oxidized and Cu2 plus is reduced. That is oxidation and reduction takes place simultaneously. This reaction is called redox reaction. Okay. So why redox? Reduction plus oxidation. That is why redox reaction. So Zn is oxidized and Cu2 plus is reduced. That is oxidation and reduction take place simultaneously. Therefore, this reaction is called redox reaction. Take another example. A copper plate is immersed or copper wire is immersed in AgNO3 solution, silver nitrate solution. Gets a layer of silver deposited on its surface. We can see the diagram or the photo or the figure. So what happened here? The something is attached or deposited on the surface of this copper. So what happened here? What is the mechanism here? We have to examine the equation for chemical reaction taking place. So for that we want the equation. So you write the equation 2AgNO3 plus Cu gives CuNO3 twice plus 2Ag. This is the total reaction, overall reaction taking place in this reaction mechanism. Okay. So 2AgNO3, silver nitrate is converted to Ag and Cu is converted to CuNO3 twice. Explain this process on the base of reactivity series. Can you explain? Yes, it is very simple because the position of Cu in the electrochemical series is in the upper portion compared to silver. So silver is in the lower portion. So silver is less reactive than copper, or we can say copper is more reactive than silver. So more reactive metal copper can displace less reactive metal silver from its solution. What is its solution here? Silver nitrate solution. So the more reactive copper can displace less reactive silver from its solution, that is silver nitrate solution, and Ag is deposited on copper wire or copper rod or copper plate. Clear? So silver is deposited on copper. Silver is deposited on copper. Why? Silver is displaced by copper because copper is more reactive. Clear? Then take another sense, that is the same equation is taken and you have to fill the blanks. Complete this chemical equation by assigning oxidation numbers. It's very simple. What is the oxidation number of NO3? In the right hand side you can see CuNO3 twice. So NO3 is -1. The oxidation number is -1. So in AgNO3, Ag is +1, NO3 is -1. Very clear. Then Cu0 is a metal or an element. Then Cu, in copper nitrate, that is cupric nitrate, CuNO3 twice, -1 into 2, NO3, 2 NO3 ions are there. So -1 into 2 means -2. To cancel -2, Cu should get +2. Okay, so what is the oxidation number of Cu? That is +2. Okay, then what is the oxidation number of Ag? That is 0. Why 0? Silver is a metal, silver is an atom, so oxidation number is 0. So once again listen, in AgNO3, the first blank is filled by -1. In CuNO3 twice, the first blank is filled by second blank, totally second blank. That is Cu, that is 2 plus. Above Cu you write 2 plus. Then above Ag you write 0. That's over. Okay. So like this we can see any example and we can write the oxidation reaction and reduction reaction. At the same time you have to see about reducing agents and oxidizing agents also. Okay. So this is an example for redox reaction again. Okay. Then listen. Which ion is responsible for the change in color of silver nitrate solution to blue after some time? So when silver nitrate is converted to blue color by immersing a copper rod in it, we can see that copper nitrate is formed, cupric nitrate is formed. Here Cu2 plus ion is formed. That Cu2 plus is the reason for what? Cu2 plus is the reason for blue color formation. Okay. Which metal was oxidized in this case? No doubt copper is oxidized. Cu0 is converted to Cu2 plus. So copper is oxidized. Which metal was reduced? Which metal was reduced? No doubt Ag plus is reduced. So Ag plus is converted to Ag0. So a decrease in oxidation number, addition of electron. So silver is reduced. Okay. Write equations showing oxidation and reduction. What is the oxidation reaction here? Cu gives Cu2 plus 2 electron. That is the oxidation reaction. What is the reduction reaction here? Ag plus electron gives Ag. That is the reduction reaction. So it is a redox reaction because oxidation and reduction take place simultaneously. Therefore, that type of reactions are called redox reactions. So altogether we can say that there is a consolidation. That means metals are having high reactivity displace the metals are having less reactivity from their salt solution. That is the conclusion actually. Metals are having high reactivity displace the metals are having less reactivity from their salt solution. Such chemical reactions are known as displacement reactions. What's the name? Displacement reactions. Metals with higher reactivity get oxidized. Metals with higher reactivity. Example in zinc and copper, which is the higher metal having higher reactivity, zinc. So zinc is getting oxidized. Okay. So metals with higher reactivity get oxidized and those with lesser reactivity get reduced. No doubt. Displacement reactions are redox reactions. Displacement reactions are redox reactions. Okay. Then you see another example, another experiment. Here 5 vessels are there. In each vessel, solutions are taken. The first vessel, copper sulfate solution is taken. The second vessel, again copper sulfate solution. In the third vessel, third beaker, zinc sulfate solution. In the fourth vessel, silver nitrate solution. And the last vessel, magnesium sulfate solution. Okay. In the first vessel, that is magnesium ribbon or magnesium rod is immersed in copper sulfate solution. In the second example, Ag, silver is that means immersed in copper sulfate solution. In the third vessel, magnesium rod is immersed in zinc sulfate solution. In the fourth vessel, magnesium rod is immersed in or dipped in AgNO3 solution. And the last vessel, copper rod is immersed in or dipped in magnesium sulfate solution. Observe the picture given below. Then based on the reactivity series, predict which among these undergo a displacement reaction. Complete the table. A table is given here. You have to complete the table also. For that, you are given a small piece of the part of our electrochemical series also. So, potassium, sodium, calcium, magnesium, aluminum, zinc and so on. So, then take first case, is it a displacement reaction or not? So, magnesium is a more reactive metal that is dipped in copper sulfate solution. What happened here? No doubt copper is displaced by magnesium because magnesium is highly reactive compared to copper. So, first reaction is the displacement reaction. So, you fill the table. So, in the table, displacement reaction takes place, no doubt. Okay. Then you take the second one. Silver is immersed or dipped in copper sulfate solution. You see the position of copper and silver. So, copper is in the upper portion compared to the silver. So, silver is less reactive. So, copper can displace silver from silver nitrate solution. Copper can displace silver from silver nitrate solution. But in this case of this experiment, silver is dipped in copper sulfate solution. Is it possible to displace copper from copper sulfate solution by silver? Not possible. So, silver cannot displace copper from copper sulfate solution because silver is less reactive. So, you complete the table, does not take place, okay. Then the third one, magnesium and zinc sulfate solution. So, no doubt magnesium is more reactive compared to zinc. So, magnesium can displace zinc from zinc sulfate solution. So, it is a displacement reaction. So, takes place. So, that is magnesium zinc sulfate, fill the blanks, takes place. Okay. Then the next one, the fourth one, what happened? Yes, magnesium dipped in silver nitrate solution. No doubt silver is very, very less reactive compared to magnesium. So, magnesium can easily displace silver from silver nitrate solution. Okay. So, it is a displacement reaction that is takes place. The last one, what about last one? Copper dipped in magnesium sulfate. No doubt copper cannot displace magnesium from magnesium sulfate solution because magnesium is highly reactive compared to copper. So, answer does not take place. Okay. So, similarly we may get different solutions, or we may get different atoms or metals. So, then there may be a question whether it is displacement reaction or not. So, you have to write the answer by checking the position or by thinking about the position of different elements in the electrochemical series. Now, you can say different elements having or different metals having different reactivity. So, based on the difference in reactivity, some devices are prepared and they are called galvanic cells. Now, nowadays we know so many cells are there: dry cell, mercury cell, lead storage cell, nickel cadmium cell, and then lithium ion cell. So many types of cells are there. So here there is a cell that is called galvanic cell. The first and old concept, that is galvanic cell. You know voltaic cell, you know galvanic cell. Why the term galvanic? Galvani, the scientist. Why the term voltaic cell? Volta, the scientist. Okay, you have learnt that metals differ in their reactivity. Metals are differed in their reactivity. Zinc is more reactive than copper, copper is more reactive than silver, and so on. Galvanic cell is an arrangement in which the difference in reactivity of metals is used to produce electricity. So, galvanic cell is a device which can convert chemical energy into electrical energy. Galvanic cell is an arrangement in which the difference in reactivity of metals is used here. Difference in reactivity is used here to produce what? To produce electricity. So arrangement of apparatus can be seen in the diagram. It is very simple. In this diagram, we can very easily see that, there is a vessel, beaker, consists of zinc sulfate solution. A zinc rod is immersed in it, and the second vessel consists of copper sulfate solution. A copper rod is immersed in it. A salt bridge is there for getting internal connection, and a voltmeter is connected in the external circuit. Okay, so this is the diagram of a galvanic cell. A direction of electron flow is also indicated as an arrow mark. Okay, so we can see here the arrangement is clear, and here two beakers are taken, one containing 100 ml zinc sulfate solution and the second containing the same amount of copper sulfate solution with the same concentration. That means here copper sulfate solution and zinc sulfate solution are taken having same concentration, that is 1 mole of zinc sulfate in 1 liter of water. There is copper sulfate, zinc sulfate solution. Similarly, 1 mole of copper sulfate, 1 mole of copper sulfate is taken in the 1 liter of copper sulfate solution. That means if you are taking 1 liter zinc sulfate solution, that consists of 1 mole zinc sulfate in 1 liter zinc sulfate solution. And if you are taking 1 liter copper sulfate solution, it consists of 1 mole of copper sulfate in 1 liter copper sulfate solution. And zinc rod is immersed in or dipped in zinc sulfate solution. Copper rod is dipped in copper sulfate solution. A salt bridge, a U-shaped glass tube consists of an electrolyte is taken as a salt bridge for internal connection, and a voltmeter is connected in the external circuit. Okay, that's about the diagrammatic representation of a galvanic cell. So galvanic cell is a device which can produce electricity from chemical energy, and we will discuss later about this galvanic cells and other cells, etc. The reactions, mechanism, etc. we will see later. Thank you for your observation.